Hey everyone, welcome back to Dreamspace TV here in One Microsoft Place in Dublin. This is episode 4. We have lots planned for today, so let's get going.
Yeah, so in today's episode, we're going to recap over the extension challenge in the last episode. We're going to discuss AI for accessibility, and we're also going to create, using variables and conditions, our own inclusive game. So Amanda, we might go through the solution for the last episode's challenge.
Yeah, definitely. And in the last episode, we covered a lot of stuff, right?
Yeah.
We wanted to kind of go back over, remember the concepts that we had done in our visual programming and look at how we could do them within our Python program for Microbit. So you can see here, what I've done is I've reopened my project from the last time. And I can see clearly what we covered. Remember, we used our comments. And I said at the time, it's really handy because when we reopen our projects, we can see in our comments what we've done. So I can see basic sequences, operations, functions, loops. So we did tons of stuff, right? But if I go down, I can see there was a temperature monitor. And that's kind of what we based our extension challenge on. So what we asked you to do was to kind of use this kind of basic building blocks for the temperature monitor to create another monitor, but this time using the input of light sensor. Okay, so I'm going to do this with you, and hopefully, if you didn't get through this, don't worry, by the way. We're really going to, for the extension challenges, we're really going to try and push you, okay? Remember, you can always toggle back to blocks if you're getting stuck on things, okay? But it'll be interesting to see how you got on with this. So remember, similarly to, I can use this as a little guide for myself, right? So similarly to here, the first thing I'm going to do is create a function, okay? Now, normally what we did was we brought in an input. So we brought in this instance, we brought in shake, and then remember we altered the name of our function and stuff like that. We could do it again, or what I might do this time is just create the function kind of from scratch, from nothing, just to show you that it doesn't always have to come in with the input. You can actually make a function no matter what, once you use the syntax or the rules, all right? So remember with our function, the first thing we did was define, so DEF, and then we named it. So Niamh, what will I call this one?
Light sensor.
Light sensor, cool. So I'll do lowercase l and uppercase s for sensor. And remember then for my function, I have to do my brackets. I'm going to open my bracket. It will bring in both. And then remember, very importantly, which I did forget in the last episode when I had a bug, I need my colon. Okay. And now I'm going to return, and remember we're indented now because we're now going to add the unit of code that we want this function to contain. Now, if I use my guide up here for temperature, it's going to be very similar, except obviously it's not temperature, it's light, and the numbers are going to be slightly different. We're not talking about degrees Celsius here. So let's go with our first condition, which remember will always begin with if. So we're going to do if, and this time instead of the input of temperature, it's light, so I'm going to type input because I'm still taking this from my input menu. It's still information that the Microbit's taken in. Except I'm going to do dot light, and you can see it's coming up here for me, light level, which again is an inbuilt function. I know that because of the brackets, okay? If I say input light level is less than, might say 100.
Yeah.
Okay, is less than 100, and then I'm going to do colon, down, and I'm going to say, what would we say this time? Basic dot show,
Maybe
we do
bright.
Yeah. Well, less than 100 would be lower.
Oh, so maybe dark.
Yeah, dark, I think. String, let me see, and we might say dark. Okay. Now, what I could do is, and maybe you did this, by the way, we could come down a level. Now, remember, because I've gone return, it's still, the next line of code, if I left it as it is basically going to execute within this if condition. So if I'm finished with that condition, I need to backspace and come out of that. And I have two options here. I can either give another if condition, which would be elif, else if, or I can go straight to else, which would be basically anything that isn't less than 100. So in this instance, I might just do that to keep it nice and simple. But we're going to be working on conditions more today. You might have done elif something and elif something again, and then, but just make sure you always finish with else, because generally, from an etiquette point of view of coding, that would be the best thing to do. But I'm going to go straight to else, and I'm going to say basic.show _ string bright. Okay, So there's a very basic light sensor challenge, okay? Now, that is my function, but Niamh, we always talk about this, and I'm going to mention it again. We said it in the last episode. If we're going to create a function to use it,
we need to remember to call it.
We need to call it, exactly. So if I go down a line and I come back out and back out again, now I'm going to need to call my function. And I'm going to use this line. I'm actually going to copy this line and paste it. Now it's after indenting itself, so I need to bring it back out again, so it's a new line of code. And it's input.onGesture, gesture.shake. Now we've used shake up here, so I can't do that again. So I'm going to click on shake, I'm going to backspace, and I might do a different gesture, a different movement. So maybe we go tilt left?
Yeah.
Yeah. And again, here is where I call my function. My function name is here for me. It is light sensor. And there we go. Now let's see, does this work? I'm going to bring back in my simulator, and I'm going to, that's my on start instruction again.
So we have to tilt it left.
Tilt it left, and you can see it's saying bright because it's 128 is the value. Now if I change this value and I make it down lower to 87, and I tilt again, sorry, we'll go back. There we go, dark. So it is responding according to the conditions I said. And again, similar to the temperature, I can manipulate this on my simulator to test if it's working or not. So that was a basic solution. Again, just to emphasize, you could have done multiple conditions here. Yeah. You could have come over and tested and said, I'm going to do less than 50, I'm going to do between 50 and 100, and then greater than 100. It's up to you, right? But that was just a basic solution, Niamh, that I was thinking. The only thing is I would say is we're about to move into today's kind of episode and today's challenge. And one of the things we really want to think of today is keeping our code and our designs inclusive and accessible. So in this episode, we really want to focus on accessibility and making sure that all the programs we develop are as inclusive as possible. And we know in Microsoft that technology can really help with this area of accessibility. So how about we have a look at that for a second, Niamh?
Exactly. So we have 5 AI for good pillars here at Microsoft, and as you mentioned, AI for accessibility is one of them. So let's take a look at the video and we'll see some examples.
We have so many pupils who are non-verbal, but still have so much to say.
I want the exact same information that my hearing friends have.
There are barriers to communication everywhere, but I think it's time we look at the barriers as opportunities to reach out to everyone.
Soundscape fills in a lot of the mental map as you move.
Approaching intersection.
You can just put it in your pocket and go.
With ALS, you become locked in. But we see technology as a way to give back what ALS has taken away.
There's no better feeling than to hear a child say something that they've wanted to say and the look on their face after they've been able to say it.
When it's reading, I see spaces between the words. And it's easy to focus on.
Anjay realized that here was something that could change his life.
Now that I have my phone, I can see exactly what was said, and that's been a huge help to me.
The system is learning as it goes, and the accuracy has improved tremendously.
Students can pick any language that they choose to receive the information. It's like we jumped into the future.
Because communication is very important for all of us, and we just want to be together and not feel left out.
Aider les personnes avec autisme à communiquer, il y a des images.
Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
On va pouvoir remettre en place une communication qui est plus spontanée. Je crois que ça aide à recréer du lien.
Both my wife and I are totally blind, and we have a 3-year-old son that's in preschool. He can see, but his parents can't. So to be able to know what's going on at his school is everything The Seeing AI app has the ability to allow me access to the visual world. Artificial intelligence is beginning to have an impact on the lives of people with disabilities, but it's only going to grow. There is still so much out there to be done.
So in the video, you might have seen loads of different examples of AI for accessibility. For example, Microsoft Translator, Helpicto, Eye Control. However, one we find really useful here in Dreamspace is Seeing AI. So I might demonstrate that first. And Seeing AI is an app. So it can do loads of really cool things. So the first thing it can do is it can read short text. So I might demonstrate that first.
Dreamspace. Artificial intelligence for accessibility.
Deadly. Cool.
So it's really cool. Another thing it can do is it can pick up if there's a person in the room. So Amanda, if you wouldn't mind being my model.
Yeah, no worries.
Great.
One face near center, 3 meters away.
Okay, and I might just do that once more, so I might go further away.
0 faces.
And I might go closer.
One face near center. One face near center, 3 meters away.
Great. Cool. So, and that's just 2 examples. There's tons of categories at the bottom of the app. And sometimes students ask us if they're visually impaired, how do they know they're there? Well, you can hear it's clearly giving an audio output to say short text, person, etc. And one of the really cool stories I remember reading about that app, Niamh, is actually that someone who was blind was saying that it was the first time, using that was like the first time they could hear a handwritten note by themselves. Like, so independently, they could hold this phone over a note, a card, a letter, and have it read back to them. They didn't need to ask somebody, can you read this to me? And so it just shows like the power of that.
Exactly.
So now would be a good time to pause and have a think about our AI formula. Okay, so data plus algorithms plus machine learning. And maybe think about how does that app work alongside that formula? All right, so hopefully you could have a good think and a good discussion there about how the AI formula we talked about would have been applied as we developed the Seeing AI app. Now there's tons of sections, as Niamh showed you there, to the Seeing AI app, so they would have all needed nearly to be individually trained, because obviously anticipating a person is different to anticipating text. But it would have got loaded with lots of data that can recognize language, handwriting, object recognition, such as cars and people and buildings, all that stuff. And obviously it's using our algorithms to work alongside that, and it will learn as it goes. So all those key features are included. Now, the idea of accessibility will be crucial for today, and actually we'd love for you to keep it in mind moving forwards. We want to make sure that when we program, we keep the stuff as inclusive as possible. So when we're doing today's challenge, that is going to be a big, big focus for us. And it's actually related to the global goals as well. So if I look at my global goals, goal number 10 is reduced inequalities, which is about making sure that the world is more equal for everyone and more inclusive. So I'm going to head over here. We are already on our extension challenge page. I'm going to go make a new project. So maybe you can do that too at makecode.microbit.org. So I'm going to go now. Okay, so new project. And I'm going to say Python. What episode we're on? We're on episode 4. Create. Okay, so we're into a new project here, and like before, it automatically thinks it's visual programming, it's on blocks. So I am going to toggle over to Python. And Niamh, you're going to go along with me on this one just to keep an eye on my code.
Yep, I'm going to join in today.
Brilliant. So I'm just after getting rid of the simulator for the moment, because I'm kind of happy enough that I can just code away here for a little while before I do my testing. And I'm going to, again, these automatically came in, so I'm going to delete them. So I've just started on a fresh, clean line. There's nothing on it, right? Like before, I think we'll comment as we go, just to keep ourselves up to speed on everything. So I'm going to use the hash symbol to say we are going to create a conclusive game. And what the game is going to be is rock, paper, scissors, which we're all very familiar with. But we want to maybe just make sure that when we do this with the microbit, that we make sure it's accessible and inclusive. So I'm going to say inclusive game of rock, paper, and scissors. Okay, and then I'm going to go down a line. So now will be a good time to pause and first of all play the game rock, paper, scissors, and then also note down the decisions you are making when you're playing the game. Okay, so hopefully you had a bit of crack playing rock, paper, scissors there. Everyone has, what confuses me is I used to play this with my students all the time, and they have different rules and stuff, which always used to catch me out. But we'll just do rock, paper, scissors, go, Niamh, will we? Okay, ready? So, okay, so we were actually playing this earlier, and Niamh beat me, so that's probably that's the first time I won. That's why I did
it's a draw.
That's why I did a little cackle there. Okay, so what we want to think about now is what are we actually thinking when we play the game, right? So what I'm thinking anyway is, first of all, in my head, I'm thinking, okay, I have 3 options here. I have rock, paper, scissors. Then I pick one, and I just pick one at random. I know some people always go with the same one, or they have a little formula for what they do, but I always just randomly pick in my own head anyway. And then obviously at the end of that, then we display it with our hand. So there's like an output at the end. So bear that in mind, because we're going to need to use that kind of knowledge as we develop our game here. Okay. So the first thing we're going to come in here and do is decide what input will we use to play the game. Okay, so we want the microbit to randomly pick between rock, paper, and scissors and do something as a result of that. But first of all, we need to decide on the input. So I might go input, because we're going to obviously be using the menu, dot on, and it's going to be a gesture, I think, Niamh, will we?
Yeah. I think we could use on shake to mimic the action of when you're actually playing rock, paper, scissors.
Perfect, yeah. And you can see here, it's actually, again, the default is actually shake, all right? Because if you think about when we brought the block in, we always had to hit the arrow to change it. So the first option that comes up is shake. The other things that default, remember, are first of all, we need to define the function. And it brings an automatic name in for us, but I'm going to come back and change that in a moment. It also brings in the fact that a little line here saying pass, which is just identifying that there needs to be some sort of unit of code here within our function. And then the final line, remember, is the default line that allows us to call on the function we want to use with this gesture, whatever is written here, which in this case is shake. But we're going to go and change this now. So the first thing we're going to do is we're going to define our function name. So we're going to change this up. So I'm going to delete on gesture shake, and I think I'm going to just say play or PS for rock, paper, scissors. Okay?
That's good.
And that's the first thing. And we can see the rest is correct. I've defined, in terms of functions, remember, I've defined it, I've named it, I can see my 2 brackets, and I can see my colon, and then we're going to come in and it'll be indented. So I'm going to delete the word pass, because we're going to now get rid of pass, and we're going to put in our unit of code that this function contains. Right, so we know that with rock, paper, scissors, there's going to be 3 options, but we want these options to be at random. Okay, and to begin with, we're going to have to create a variable, which is, like we said, was something that we talked about before, but we hadn't covered just yet in Python. It's actually really easy to create a variable in Python, right? All you need to do is give the variable a name and assign it a value. All right, very, very simple. And the other thing just to note is that value can be updated. It can change over time within your program, which you might see when we test this game in a while. So I'm going to call my variable RPS, so I'm literally typing RPS is equal to, and what I want to say is I'm not going to just assign it to like one number, like I'm not just going to say like is equal to 1 or is equal to 2 or is equal to 3, because that means that it's always going to use that. I want it to be randomly picking a number. Okay, so we're going to use something called a library in Python, which are these like inbuilt things. And the library is going to be one that randomizes numbers. And I'm going to say RAND, and you can see it's actually coming up for me there. It's the first one, randint. So randint, which means random integer. Now an integer is just a whole number. So if I do my brackets here, I open my brackets, and I do 1, 3, okay? So what that means is it's going to, RPS, this variable, will be assigned a value randomly in between the integer 1 and 3. Okay, so it could be 1, 2, or 3. Okay, if it was like 1.5, 2.5, etc., that wouldn't be an integer, that's not a whole number, it's what we call a float. So they're just two data types in Python. A string is another data type, for example. So just to, you don't need to really know that, we're not going to go into it too much, but just wanted to point that out. Okay, so the first thing we're saying is when we call in the function that we want our variable RPS to pick a random integer between 1 and 3. Okay, so that's the first thing it's doing. So I might just put a comment here to say RPS will be the value 1, 2, or 3 after that step, okay? That's what that line means. The next thing I need to do are my conditions. So right now, we know that the microbit will do this. When we call in the function, it will pick the random number, but it doesn't know what to do next. It doesn't know what to do if it picks 1, or if it picks 2, or if it picks 3. So we need to now set that out, right? So let's go down and let's use our very common keyword, which we've used now a couple of times, which is if. So let's think about this. We want to say if RPS basically has picked 1 or is equal to 1. Now this is important, right? When we want to say if something is equal to, okay, especially in something like maths, right? We use 2 equal signs because 1 equal sign is always used to assign values to variables. Like you can see here, 1 equal sign assigns a value to a variable. 2 equal sign means is equal to, okay? So if RPS is equal to 1, we're going to do our colon, we're going to come down. And in this instance here, I'm actually going to do something we haven't done before, Niamh, I don't think anyway, which is show LEDs, right? Which is a different basic instruction. So I'm going to say basic.show, and I'm going to just click on my show LEDs here. Okay, so that's opened up there now. And we can see that I have, if I come down to line 9 and I come down to 13, so this whole square area here basically, that is my matrix of LED lights. And the full stop means the light is off and the hash symbol means the light is on. So let me think, I think I will say that if RPS equals 1, I want to know that that was a rock. So I think I will draw like a version of a rock with my LED lights. So right now only this LED light here is on, so I'm going to make a little square of LED lights. Now you might do something different here, by the way, which is the beauty of coding. It's completely up to you what you create. You might not even use LEDs at all. You might use a string. You might use, I don't know, a pre-made icon. Completely up to you. But I'm going to just make a little square here by changing my full stops to my hash symbols, and that should mean that that is now on. Okay, now, so I think we could pause at this point, and maybe you could get up to speed to there, but potentially you could also push yourself on and see if you can finish out the code for paper and scissors. Okay, so you might have kept going there and you might have got 2 and 3 done, but I am going to just keep moving here and you can kind of be iterating and checking your code as you go. So we've done that if RPS has picked the random integer 1, the condition is there now. It knows what to do. It can identify this situation for 1, but it doesn't know what to do for 2 or 3 yet. So that's why we have to keep going. So we're going to return. Now remember, we're still within our if condition here, so if I'm going to be starting a new one, I need to come back out of that, I need to backspace. And we talked about how we use the word elif and not else if, so we're going to say elif RPS, oh, spelled my name wrong, equals 2 and...
Amanda, I just noticed there you only used 1 equal sign.
Oh, sorry, thank you. Yeah, so that's just me in my haste. So again, sometimes the faster we go, the more mistakes we make. So apologies, that's spot on. Yeah, so again, that's really important. The double equals is equal to. So if RPS, or elif, sorry, RPS equals is equal to 2, colon, and now we decide. So I'm going to say This time I'm going to use, just to change it up, I'm going to use a string. Oh, come back. String. And I'm going to use, just use the letter P. So I'm going to decide that 2 is going to be paper. So rock will be a square of LEDs. 2, which I want to be paper, will show me P. Okay, so that's good. So now we've covered off that our variable, if our variable is assigned the value 1 or 2, it will know what to do, but it still doesn't know what to do for 3. Now you could say L if RPS equal 3, but you don't have to. So it really would be more correct for us to use else here. So that's what we're going to use, okay? Because remember, RPS is going to either be 1, 2, or 3, and if it's not 1, as your code is checked by your program, it will see it's not 1 and it's not 2, so it has to be the last option, which will be else. So I go else, colon, come down, and now I'm going to do my show, and I might go icon this time.
Yeah.
Because after using Microbit so much, I know there is a pre-loaded icon for scissors, and I am terrible at drawing a scissors with the LEDs. Someone else watching might be better. But I'm going to just pick my scissors icon here, and that should be good. So I have my function. I'm going to just double check this. My variable is going to pick a random number between 1 and 3. I've told it what to do if it picks 1 or 2 or else 3. It will be the other option. And my final thing to check here is what I need to do when I call on the function. So I've said that I'm going to use a gesture input. The gesture we're using is shake. I'm happy with that. You could change that if you wanted to tilt or something. And here we need to change this, don't we, Niamh?
Yeah, we need to call on the correct function. So we renamed our function.
Yeah, so my function
RPS.
up here is RPS, play RPS, yeah. Perfect. And I think we should be good to go. Yeah, my problems is gone. So we should test this. Now, technically, I should have really been testing this as I went. I should have updated my area where I was calling my function. And even though it might have been picking only 1, I should have just kept checking it just to see it was even responding. But anyway, remember we talked about that habit. So something we all need to work on. Now, so I have my function on shake. Let's see, let's test it out. You could even play against the Microbit if you wanted. Scissors, paper, rock. There we go, great. So it's picking randomly. It's going to pick 1 to 3, and it's going to then react accordingly. Okay. Now, we still haven't addressed what we talked about at the start of the episode, which was that we want these games to be inclusive and accessible. Right now, if I was playing this game and I couldn't see very well, or I couldn't see at all, then I couldn't actually really play along. So now will be a good time to pause and think about what you can add into your conditions to make this game more inclusive. Okay, so hopefully you got on good there and you're able to add something. So you might have different ideas about this, right? But I'm sure something that's jumped out at you, and we've looked at it before, is the music category. So even though with the CNAI app, when we used it, we were talking about how they might not be able to see, but they can hear the audio prompts to help them. So how about we assign something similar to our game of rock, paper, scissors? So I'm going to come back up, and how I'm going to do this is I'm going to what we call iterate. So I'm going to return to the top, and I'm going to come back through and improve my program. Okay, so I'm going to add another iteration here. And that is going to include, hopefully, a more inclusive piece where we add music, so that if I can't see rock, paper, or scissors, I'll know by an audio prompt what the solution was or what the answer was that came out of the output. Okay? So I'm going to come into my conditions. None of this is changing. I still have a function. I'm still picking randomly. What we will change is what happens when our condition occurs. So if RPS equals 1, we see the square LEDs, but we add another little piece in there to be more inclusive with music. So I'm going to come in here under my LEDs, and I'm now going to add some music. So I don't know, Niamh, if you have any ideas about this, but I'm just going to go music dot. And there's loads of options here. We can play tones, melodies, lots of stuff. I'm just going to go with a simple musical tone or note. So I'm going to click play tone. And you can see here that it says note .c. So I am not a musician, so that's a heads up for everyone. It might not sound the best, but I'm going to click on C, and I might just change that to A. Yeah, in the hope that A exists. Yeah, okay, because I'm not a musician. Okay, so I don't know, what I was thinking maybe was that if it's rock, it's 1 beat, paper is 2 beats, and scissors is 3 beats.
3 beats.
So that there's like a distinguished thing between it. Okay, so, right, so that should be if RPS equals 1. Now, we might just go and test that and just see that if the square occurs, do we hear a musical note as well? So I'll just check my volume is up too. Here we go, gonna come in and test. So we're waiting. Now this is only going to occur, remember, if it picks 1. That's the only one I've added it into so far. So we're only going to see or hear this if we see a square. Of course, we won't pick a square. There we go. Okay, so it's working. So I'm happy that the musical output is working when we have the condition for 1, which is rock. Okay. So we just are going to go now through this and add it into the other, and I'm going to be cheeky and I'm going to copy and paste it. So I'm going to copy this and I'm going to come into my condition for 2. 2 is going to show me the string P, but maybe now this time I'm going to paste my line for tone once and twice. So I'm going to get the note to play twice, except this time I might change it up. Maybe I want note G, and these are just different. Sorry, if I go back there again. You can see there's like, for people who are musical, sharps and so on. You might need to play around with that to understand exactly the ins and outs of it, but it's pretty cool that it does that. And maybe I'll go F. Okay, now I have no idea what this is going to sound like, so bear with me. And then I'm going to take this again. So now I have 2 lines, so I can even be even quicker, which we love. And I'm going to come down. And this time for my else, which remember would be if it picks 3, and we're going to see a scissors icon. And now maybe we're going to hear 3 musical notes. So I'm going to change just the notes up again to maybe a D. What ones haven't I used, Niamh? B?
B.
Yeah. And then music dot, one more. Music dot play tone. And sure, I'll leave it at C. Okay. So let's just double check this before we rush. So we have 1 is a square with 1 note. 2 is going to be a string P with 2 notes, and then 3 is a scissors with 3. So let's just check this works. We're still calling on the same function. That hasn't changed. Let's bring that out and click on shake. Okay, so there was 2, so that's perfect. Same again. Really likes paper. That's 1. Okay, perfect.
Very good.
So that's working away great. Okay, so what we want you now to do is just get yourselves up to speed, and then we might just recap and make sure we've covered everything out.
So we first looked at our extension challenge from the previous episode, and then we covered AI for accessibility, and we looked at the Seeing AI app in particular.
Yeah.
And then we moved on to Python, and we covered how to create our very own accessible virtual rock, paper, scissors game. So in today's extension challenge, we want you to create your very own accessible game. And we want you to bear in mind that you're going to have to use conditions similar to Amanda did in her program, and also keep it very simple instructions.
Yeah, definitely. Can't emphasize that enough. Please keep the game simple. Sometimes people completely overthink it. So a variable, a couple of conditions, use your imagination, come up with some sort of system where you win or lose. That's all we're looking for with the game. Thanks so much for joining us this time with episode 4 of Dreamspace TV. We got lots covered. We do want you to join us again in episode 5 next time, where we plan on improving our skills and ultimately hoping that you'll be able to enter the Do Your Bit challenge as well. We'll chat to you then. See you. Bye.
Bye.